this video, we're going to take a look at section 5.5 on systems of inequalities in two variables. Before we tackle systems of inequalities, we will first discuss how to solve just a single inequality of two variables. We will have linear inequalities of two variables, where the inequality may look like this, but with the equal sign replaced with an inequality symbol. But we will also have some nonlinear inequalities of two variables as well. To solve a linear inequality in two variables, there are actually two methods that we can use. There's the test point method, which is outlined here in the notes. This method is actually not my preferred method for solving these inequalities. I don't mind it that much, but I find my students don't really like it, especially when they find out there's another way to approach it that is a lot easier, I think. I think most people would consider it to be a lot easier. The test point method is a little bit tedious because you have to pick a point and then plug the numbers from that point into the inequality and see if it's true or false. When there's just one inequality, it's not too bad. But when you have two, like when you have a system and you have like two inequalities, there's 4 different regions. You might have to test 2 or 3 of those before you find the region that works. And you have to test it in both inequalities, right? So you pick a point from a region, you plug it into both inequalities to see if it works in both of them. If that one doesn't work, you have to pick a different point from a different region, plug it into both. It's quite a bit of computation. And there is another method you can use that doesn't involve that much, computation. And that's the method that I'm going to outline underneath this, right? So this is not actually in the notes. It's sort of the unofficial shortcut. And generally, I don't give shortcuts for problems unless the shortcut is 100% effective. A lot of shortcuts are shortcuts that work 90% of the time. And for a lot of students, those are good odds and they don't mind taking that chance. But I don't want to teach a shortcut that only works 90% of the time and gets you the right answer only 90% of the time. I'm only going to tell you a shortcut if it works 100% of the time. And that's what we have here. So what you could do instead, and I think you'll find this is less tedious, less writing down, less computational, is first solve your inequality for y, and that's probably the hardest part of this process. If possible, now I didn't write this out, but sometimes you may not be able to solve for y for various reasons. And what we will do in that case is we'll adjust. We'll find some creative way of adjusting for that so that we can still use this process. So the process can still be used even if you can't solve for y, but it will be different. It'll behave differently. So solve for y if possible, then graph as an equation. So take your inequality, but graph it like it's an equation. In the case of a linear inequality, the graph you'll get here is a line. And then you'll have to decide whether that line should be solid or dashed. Now I say decide, I don't know, maybe that's a bad choice of words on my part. It's not really a choice that you get to make. I mean, there's a right answer and a wrong answer here. But you'll either graph it as a solid line or a dashed line. You'll graph it as a solid line if it has an equals to in it. So if it looks like this, less than or equal to, or greater than or equal to, then the graph will be a solid line. But if it doesn't have an equals to, if it's just greater than or less than, then you have to graph the line as a dashed line. So make sure you're careful to remember that detail. It's analogous to using brackets or parentheses from when we graph on the real number line. Now, previously when we did inequalities, we graphed the solution set on the real number line, but that's because the inequalities we did previously had just one variable, so we only use one axis, which is the real number line. Because these have 2 variables, we're going to have to graph with 2 axes, which means we're going to have to graph on the Cartesian coordinate system. And so brackets and parentheses don't work in that case. So the 2-dimensional equivalent of brackets or parentheses is graphing sounds kind of redundant, graphing your graph as a solid line or as a dashed line. Solid is like a bracket, dashed is like a parentheses, right? And then once you've graphed your equation and you've decided whether it's solid or dashed, the last step is either you will shade above your graph or below your graph. You'll shade above if it's y is greater than. I'm sorry, I kind of did a bad job writing that out there. I'm doing another similarly bad job here. Let me try that again. Right? If it's y is greater than, you shade above. If it's y is less than, you shade below. And this way you don't have to do any computations. You don't have to take any points. You don't have to plug any numbers in. It's just quite simply either you shade above the graph that you've drawn or you shade below the graph that you've drawn. All right, so let's try this method out on our first example here. Okay, so we have 3x minus 6y is greater than 12. So step one, we have to solve this for y. So I'll start by subtracting the 3x to the other side. And I'll write the result over here. So we get negative 6y is greater than 12 minus 3x. Then you divide by negative 6 to get y by itself. That'll give me y here. Now when I divide by a negative on both sides of my inequality, this rule is still in effect. You flip the symbol around. So now this will be a less than. This negative 6 divides into both terms here. So 12 divided by negative 6 is going to be negative 2. And then negative 3 over negative 6, negative divided by negative will be positive. 3 over 6 reduces to 1/2. And then the x, I'm just going to copy down right next to that fraction. All right, so that's step one. Solve it for y. All right, step two is to graph this as an equation. Now, I'm not going to write this out every time, but this time I'll write it out. We're going to graph y equals negative 2 plus 1/2 x. So, and this is a linear equation, so we're graphing a line. To graph a line, it's in the form of y equals mx plus b, except it's backwards, right? So m is the number in front of x, which is 1/2, right? So my slope is 1/2. And here b is equal to negative 2. I'll use a different color here. B is equal to negative 2, which means we're going to start at the point 0, comma, negative 2. Negative 2 is my y-intercept, right? So I'm going to start at 0, comma, negative 2. So it's negative 1, negative 2 right here. The slope tells me to go up 1 and to the right 2 from there, right? So I'm going to go up 1 to the right 2. I end up right here. And then I'm going to draw a line connecting those 2 points. I'm probably going to do a really bad job with the setup I have here of making this line a straight line. Before I go to connect those points, because out of habit, because you've graphed a lot of lines in a lot of different math classes, and when you plot the 2 points, you just go right away, right? Connect the 2 points. But we have to make a decision first. Should the line I'm about to draw be a solid line, which is what I would normally draw by default, or should it be a dashed line? And if you go back to the inequality symbol, there's no equals to here, so I should draw this line as a dashed line. And so again, I'll do my best, but it's probably not going to look that great. So something like this, right? Connecting a straight line, connecting these 2 points with a straight line, but it should be a dashed line as you see here, right? I'll try to draw that in a little bit better. Okay, and it goes forever in both directions like this. Okay, and then step 3 is to either shade above or below. So again, we have to make, I keep saying we make a decision here, but there's a right decision and there's a wrong decision. So when I say make a decision, I'm not saying it doesn't matter which one you pick. It could be either one. It's given the information in the problem, you have to decide which one is the right one to do, right? And in this case, the correct answer is to, let me pick a different color here, shade below. Now you want to be careful because, again, as I mentioned on the last page, greater than is above, less than is below. And if you look at the beginning of the problem, you might say, oh, this is a greater than, I'll shade above. But that's a mistake. I was more specific than just greater than or less than. I said, if it's y is greater than, you shade above. And if it's y is less than, you shade below. And so we don't have just y here by itself. That happens here. And here, it's y is less than because the symbol had to get flipped around the other way, which means we should be shading below. So everywhere below this line, every point below the line is a solution to this inequality. Let me see if I have a different way to shade this in. Let's try this. We'll pick a different color here. All right. So we'll shade below. Let's see if I can make that a little bit bigger. Okay. And you want to try to stay in the lines. And so this entire region is the solution set to the inequality. All the way down to the corner there. All right. And over here as well. Right. Okay. So that is how that process works. Solve for y, graph it as an equation, shade above or below. Okay, let's take a look at another example. This time it will be a nonlinear. So that's how the linear inequalities will work. Again, we haven't looked at a system of inequalities yet. This is just a single inequality. Right? In this case, step 1, solve for y. We can't. You could try. You would subtract the x squared to the other side. You get this. So don't write this down because it's a dead end. But then to get y by itself, you'd have to take the square root of both sides. And that's where things get messy. So you really could force this if you wanted to. But remember, when you take the square root of both sides, you have to do plus or minus. And it does weird things. For the plus case, it kind of stays the way it looks right now. For the minus case, you have to flip the symbol around the other way. So it basically splits into two different inequalities that you have to juggle at the same time. And you have to graph both of them. And it's kind of a messy graph. And then you have to figure out which region satisfies both of them at the same time. It's going to be a mess. There's an easier way. If that was the only way, okay, then we have to do it. But there's another way to do this. We just say we can't solve it for y because it gets too messy, right? So let's not go that route. Let's just not try to solve for y this time, right? So step 2, so we're just going to skip it. I know it's kind of weird, right? You have a process where this is the first step, and usually you have to do the first step before you can move on. But this process is kind of strange in that if you can't do the first step, just skip it and move on to step 2. Step 2 is to graph this as if it were an equation. So we're going to graph x squared plus y squared equals 4. And this is one thing I really like about this section. It has us revisiting topics that we haven't seen in a while, which is really good to be doing at the end of the semester with the final exam on the horizon, right? And I covered this section in a couple of my face-to-face classes last week, and many of the students did not recognize this. They didn't remember what this graph would look like. And so let me remind you, this graph is a circle, right? So this is the graph of a circle, and this is something you need to know for the final exam. The formula for the graph of a circle, sorry, I don't know why that came out garbled like that. Let's try that again, is x minus h squared plus y minus k squared equals r squared, right? H and k are your center. Let me scroll down a little bit more. So your center of your circle is at h and k, and r is the radius. All right. So in this case, h and k, it's a little bit tricky. It's really, they're being nice, but in a way, it makes it a little bit harder to figure out. there's no number here with x. Like h is the number that's with x. There is no number with x. And same thing with k, right? It's the number with y. There is no number with y, which means these are both zeros up here. This is like x minus 0 squared, right? H is 0. K is also 0 for the same reason. And so this is going to be 0, 0. Right? The radius is not 4. The radius squared is equal to 4. And then we take the square root of both sides to get that the radius is actually equal to 2. So this circle is centered at 0, 0 and has a radius of 2. So the center is here. The radius is 2, so we want to go 2 away from the center. 2 to the right would be this point right here at 2, 0. 2 up would be right here at 0, 2. 2 to the left would be at negative 2, 0. And 2 down would be at 0, negative 2. So I just mark those 4 points. And again, I'll do the best I can to draw a circular shape connecting these. Again, the setup I have at home, it's not a touch screen. So I'm kind of doing this blind, if you will. And it gets a little messy sometimes. Before I go to draw the circle, I have to make a decision. Am I going to draw this circle as a solid circle or as a dashed circle? In this case, it'll be solid because we have an equals to here. Right? Because of the equals to, this will be solid. And so I'll draw this in the normal way. Connecting these 4 points as a circle. Pretend this is a circle. Okay, however this turns out. Let's just pretend it's a circle. All right. And then we move on to step 3. Now here's where we have to get creative. Because we couldn't do step 1, then step 3 has to be reframed. We have to ask the question relative to a different direction or a different, how do I say, we have to give ourselves different choices here. So the default for step 3 is shade above or below. But that's only if you could solve it for y. If you can't solve it for y, then you cannot think of it as above or below. Because y, that's the vertical axis. That's the axis that goes up or down. That's why we do above or below. If you can only solve it for x, for example, the x-axis runs left to right. Step 3 would become, do I shade to the left or do I shade to the right? With the circle, I don't know, to me, there's sort of a very natural, way to split this up into 2 choices. But sometimes I have classes that don't quite figure it out. But for a circle, to me, what's obvious is either you're inside the circle or you're outside the circle, right? So that's the way we're going to frame it for this, right? We couldn't solve it for y, so we don't think of it as above or below. For a circle, you're going to think of it as inside or outside. So either we'll shade inside the circle or outside the circle. And again, I think it's a pretty obvious, it's intuitive which one should be which, right? Inside the circle, that's a smaller region, right? That goes, that how do I say it? You're moving inward, which makes it a smaller area, if you will. So to me, that naturally would be less than. And outside the circle, you're moving to bigger areas, bigger circles. That's the area you want when you have a greater than, right? So you shade inside the circle if it's a less than. You shade outside the circle if it's a greater than. In this case, maybe I need to zoom out a little bit here. It's a less than, right? It's a less than, which means we will shade inside the circle. So let me get the other tool out. And this time I don't want a big pen mark because I don't have a very big area to shade in. So we're just going to shade in, I guess we'll do green here. Excuse me. We're going to shade in this little area right here. Just inside the circle. Stay in the lines. All right. So every point inside the circle is a solution to this inequality. All right. So that's how you adjust to the nonlinear inequalities if you can't solve for y. You just skip that step, you graph it as an equation all the same, and then you change the question for step 3 given whatever the circumstances are. And usually the only 3 I can think of is if you could solve it for y, it's above or below. If you solve it for x, if that's an option, then it's left or right. Left is less than, right is greater than. And if it's a circle, it's inside or outside. And I really feel like that's the only 3 situations you'll encounter. So, all right, let's see what's on the next page here. We have one more single inequality, and then we'll look at a system here, a couple of systems. All right, so this time, this is nonlinear, right, because the x is squared. However, it's solved for y. So this can happen too, right? So sometimes you can't solve for y. Sometimes it's already solved for y. So I don't have to do any work. It's already solved for y. So we'll go ahead and move on to step 2. We'll graph as an equation. So we're going to graph y equals x squared minus 9. Again, you'll have to remember when the equation looks like this, what does the graph look like? This is a quadratic function. The graph is a parabola. And for a parabola, we want to find the vertex. In this case, so if you remember this form of the equation, x minus h squared plus k, the vertex will be at h comma k. And in this case, h is 0, because again, there's no number here with the x, so h is 0, and k is negative 9. So my vertex is at 0 comma negative 9. So that's going to be a ways down here. Look, this is negative 2, negative 4, negative 6, negative 8, negative 9. Right here. All right. And then we'll need at least one more point. The vertex is really the most important point. The parabola is going to bottom out at this point here, and it's going to be symmetric with respect to the y-axis. I just need one more point, so I'll just plug in x equals 1. I'll just kind of do a chart like this, right? I'll plug in 1 for x. I get 1 squared minus 9. That's going to be 1 minus 9, which is negative 8. So for x equals 1, we get negative 8. The symmetry means I will also have a point over here because the axis of symmetry in this case is the y-axis. And that's enough for me to graph this. Now before I draw my parabola, again, instinctually I just want to draw a line connecting those 3 points in a U shape. But I have to make a decision here. Is it solid or dashed? And in this case, unfortunately, it's going to be hard to draw, but it's a dashed parabola, right? There's no equals to here. So we're going to have to do this as a dashed U shape. So something like this. Oh gosh. Okay, I'm going to try to start over. That went pretty badly. It's just hard for me to draw in here. Maybe I'll just kind of start closer. Okay, I just did like a straight line right there. Okay. Let's try to... there we go. Okay. Okay, I don't know what I'm doing here. Sorry. Trying to think if there's an easier way for me to do that. Maybe I should do bigger lines. There we go. Maybe that'll help. Okay, so instead of small little dashes, I'll do big dashes. That helped a lot. Okay. Okay. And of course it goes on like that forever. Now, you might be tempted for step 3, because, you know, a circle, clearly there's an inner region and an outer region. But with parabolas, you can see that in the same way. You could say, well, there's inside the parabola, which would be this area right here. And then there's outside the parabola, but you don't want to frame it that way, right? You want to stick to the script in this case, right? We were able to solve it for y, right? We did step 1. It's solved for y. So the proper way to do step 3 is shade above or below. You want to stick with that dichotomy, right? I was trying to avoid using the word dichotomy because I know it sounds kind of scary, but just a dichotomy is there's 2 choices, right? There's 2 things that can happen, 2 ways to think of it, right? In this case, because it's a less than, we want to shade below the parabola. Then you might say, well, which way is below? If you're having trouble figuring out, like if you're, the orientation is kind of hard to figure out, just pick a point somewhere on the parabola, just some random point, and then move down from there. Whichever region you end up in when you move down, that's below, right? So if I pick this point on the parabola and I move down from that point, I'm in this region down here. I'm outside the parabola if you want to think of it that way. So down is on the outside, up would be inside the parabola. I want to shade below. That's going to be outside the parabola if you want to think of it that way. So let me switch here to this one. This time I do want a big pen here. So, all right. So again, try to stay in the lines. And then everywhere below. So this whole entire region out here is all below the parabola. And we'll go over here, same thing. All right. And I kind of, because it's just a big space here, but if I continued, maybe I should have continued, to draw the parabola going up. It's pretty vertical, but again, this region here is below, right? So again, if I pick this point here and move down, this is still below, right? So this is also below the parabola. I know it's kind of weird to be, really it's kind of to the side of the graph, right? But it's below a point that's on the parabola. So this region is below the parabola as well. So that's what that would look like if you drew it out more fully. Okay. So that again was another nonlinear example. Let's take a look at a system of inequalities. And we just have a couple of these examples and then we'll be done. All right. Now, I'm sorry that the formatting got a little bit sideways here, but these two are supposed to be together. So let me just write this over here. We have x plus y is less than or equal to 4. That's one of our inequalities. And we have y is less, or sorry, not less than, y is greater than 2x minus 4. So we have two inequalities. That makes it a system of inequalities. And we want to find the region where both inequalities are satisfied at the same time. And it turns out that we can really use the same process that we were just using. You could do the test point method if you want, but like I said, here's where it becomes a lot of work. The method I'm using is a lot easier. You just have to do it to both inequalities. So for both inequalities, so how do I want to write this out here? So we'll have x plus y is less than or equal to 4, and we'll have y is greater than 2x minus 4. We have to do all three steps with both inequalities, right? So step 1 here, solve this for y. There's a little bit of work to do, but it's not that bad. Subtract the x to the other side, and you're good to go. Now it's solved for y. Step 2, we're going to graph this as an equation. So I'm not going to, I don't know, I've been writing it out. I guess I'll continue to do that. Graph y equals 4 minus x. This time I'm not going to write out the details. It's a linear equation. The y-intercept is 4, so I'm going to start at 4. 1, 2, 3, 4. We're going to start right here. And the slope is negative 1, right? There's an invisible 1 here, and it's negative. And you want to think of it as negative 1 over 1, so you're going to go down 1 to the right 1. Solid line or dashed line, it's equals to, so we're going to graph this as a solid line. And so again, I'll do my best here. I'll use a different color to make that stand out. Oh gosh, that went really horribly. I'll try that again, sorry. That's not going the right way. Let me try going this way instead. Okay, that's a little bit better. All right, that way. And then I'll try. I'm evidently not doing too good going down and to the right. Okay, solid line. And then step 3, shade above or below. This time we're going to shade below because it's a less than, so we'll shade below. Now, when there's just one inequality, you would just go ahead and shade the whole entire region below. But we want to wait and see what's going to happen with the second inequality before we decide the final region that we want to shade in. But what I might do to remind myself that I made this decision, that I need to shade below, is I sometimes will do little arrows like this. Right? You can either write it down or just mentally remember that for the red line, I want to be below that line. So my final answer needs to be below the red line. But I'm not going to shade it in just yet because I have a second inequality to consider. And for the second inequality, we'll go through the same steps. Step 1, already done. It's already solved for y. Step 2, we're going to graph y equals 2x minus 4. Again, I won't write out all the details. The y-intercept is at negative 4 this time. So negative 1, negative 2, negative 3, negative 4. I'm sorry, I don't know why this is getting all broken apart here, but negative 4. The slope is 2, so think of that as 2 over 1. We're going to go up 2 to the right 1. This time, it will be a dashed line. So even with a system, it's not that they all have to be solid or all have to be dashed. It can be mixed and matched, right? So we have one that's solid, but we also have one that's dashed. I'll do this the best I can here. I should have picked a different color. All right, so that's dashed going this way. Sorry, it's a little bit off the mark there, but I think that's good. All right, and for this one, I would want to shade, because it's greater than, I would shade above. So I want to be, again, I'm not going to shade in everywhere above that line because I have to take that first inequality into account. But my final answer, whatever I end up deciding to shade in, needs to be above the blue line, right? So I'll do little arrows, again, to maybe help me remind myself where I want to be. So now I will decide my final answer, and it needs to be below the red line, but at the same time above the blue line. And you can see that's going to be this region right here. All right, so I'll try to use this one to shade that in. So there we go. Don't, stay within the lines. Don't go outside the lines. And then just shade in everywhere in between here. So, all right. And of course, I'll just keep going forever that way. Okay. So this is below the red line, above the blue line. It's the only region that does both. So you need to find the region that does both of these things, below the red line, above the blue line. If you went to this region here, it's above the blue line, but it's not below the red line. It's above the red line. So that's why you don't want to shade this one in. And again, you have similar issues with the other regions. This is the only region that does both of these things. And that's how a system of inequalities works. Let's see, I got a couple more examples here. So let's take a look at these real quick. Again, I'm sorry that these got misaligned. Let's go ahead and write this over here. We have x squared plus y squared is less than or equal to 4. So this is my system right here. This time we have a nonlinear inequality with this linear inequality. So it's a nonlinear system because of that one there. We'll go through the same process for both inequalities. So I'll just go ahead and write them out side by side. Try to perform the steps. All right, so for the first inequality, we've done this one already. I don't know if you recognize it, but we did it earlier in the video. It's a circle, right? Step 1, we can't solve it for y because it would involve taking the square root of both sides. We don't want to do that. So we just skip step 1. Step 2, we graph this as an equation. That's going to be x squared plus y squared equals 4. It's the same thing we did before. The center is at 0, 0. The radius is 2, right? So the center, okay. Lost my writing tablet for a minute for some reason. The center is at 0, 0. The radius is 2, just like we did previously. Okay, I think it seems to be stable for the moment. I don't know why it's misbehaving all of a sudden. Also, I noticed that my recording area may not have been showing the graphs earlier. Hopefully they do show up eventually on the screen because I don't want to re-record the whole lesson because of that. All right, so okay, so we were graphing the circle. Because it does have the equals to, we will graph this as a solid line. So again, I'll try to draw this the best I can. As a circle. So I zoomed out. Hopefully you can see this. Oh, okay, I'm going to try that one more time. Okay. I was doing pretty good at the beginning there. Okay, that's not too bad. And then we want to decide to shade above or below. Or, sorry, not above or below. Again, that's just my default thing to say. Because we couldn't solve for y, it's not above or below. In this case, for a circle, it's inside or outside. It's the same thing we did before. This is the same problem we did earlier. We're going to shade inside the circle, but I'm not going to shade that in just yet because I need to wait and see what's happening with inequality number 2. So let's go ahead and figure this one out. We'll start by solving it for y. We'll subtract the x to the other side. All right, and then we will graph this as an equation. So we're going to graph y equals 1 minus x. So again, the intercept is at 0, 1, which will be right here. Let me pick a different color. Right here. Right, that's the y-intercept. The slope is -1, so that means we're going to go down 1 to the right 1. This will be a dashed line. So I'll draw a dashed line connecting these points here. And we'll go similarly this way. And because this one we did solve for y, we do want to think of this as above or below. This case, we will shade above, right? Because it's greater than, we shade above. So above the line, but inside the circle, I didn't mean to slash through that, I meant to underline it. Inside the circle, above the red line, I'm going to have to zoom in on this one here. So let me zoom us in there, and then I'll try to adjust the picture so hopefully you guys can see it. It's going to be this little tiny sliver of a region right here. Wow, that's still going to be hard to shade in. It's just such a small region. Okay, right there. Try to stay in the lines. I went a little bit out there, but so that would be the solution set to that system of inequalities. These are the only points that make both inequalities true at the same time. All right. Last problem, let's take a look at this system here. Now this, again, I don't know why everything got out of alignment, but obviously the easy way to fix this one is to bring this back over here. So I'm going to rewrite this over here. Whoops. Okay. And so this is my system. Now, you might be surprised to learn that for inequalities, your system can have more than two, right? Now with equations, the rule of thumb is 2 variables, 2 equations, 3 variables, 3 equations. But for inequalities, that rule doesn't apply. You can only have 1, like we saw earlier in the video. You can have only 2, which is what we were just looking at a moment ago. But you can also have more than 2. You can have 3, or in this case, we have 4 inequalities. And there's still a possibility that there's some small region that will satisfy all 4 of them at the same time. All right, so let's go ahead and try to work through this one. You just have to do the same process we did before. It's just we have to do it with 4 different inequalities instead of just 2. Right? So for each one, we're going to solve for y, if possible, graph, and then either shade above or below. Right? So let me try to organize these here. I guess I'll do it like this. And then I'll do x is greater than 0 here, and then I'll just have to skip over here where you can't see probably, but so maybe I should, I don't know if I want to zoom out either. Let me do this. And then we'll pan back over when the graphing becomes relevant. We'll have y is greater than 0. All right. Now let me see if you can see all that. And it looks like you cannot. So let me pan over even further. All right, so maybe like this. Okay, it looks like that's within the recording window. Okay. So, since it's the last one, but since I put it on the left-hand side, we'll just do this one. It's pretty easy. Step 1, already done. It's already solved for y. Step 2, we're going to graph as an equation. Wow, what is wrong with me? Graph as an equation. So we're going to graph y equals 0. Now, we have to graph it on this Cartesian coordinate system. Y equals 0 is the x-axis, right? So panning back over here, y equals 0 would be this line right here. I'm not going to be able to trace this line. So basically, you just want to trace the x-axis. I'll try it again. Oh boy. Oh gosh. Okay. Let me try that one. Oh, okay, that went even worse there. I'm going to try one more time. I'm afraid to move my writing tablet because it was being finicky earlier. But it'd be easier if I could move my writing tablet. Okay, that worked out pretty good. All right. So this blue line here. And because it's greater than, we want to shade above. So I'll do little arrows to remind myself I want to shade above this line right here. All right. So this is y equals 0. I'll pan over just to make sure. Hopefully you can see that. All right. So that takes care of that last inequality. Let's go ahead and do this one next. I'll just keep going in order here. So this one we're going to solve for y by subtracting the 2x to the other side, we get y is greater than, sorry, it's not greater than, why am I getting these wrong? Less than or equal to 4 minus 2x. Step 2, we're going to graph y equals 4 minus 2x. And so I think we've done this one already. We start at 4. So 1, 2, 3, 4. I'll show you the graph here in just a second. And then we're going to go down 2 to the right one. I think we had 1/2 earlier, didn't we? So think of this as negative 2 over 1. We go down 2 to the right one. It has equals 2, so this will also be a solid line. Right, so we're going to graph this as a solid line. And so I'll go ahead and bring this back over here because it's going to be hard for me to do on my writing tablet when it's way over there. All right, so there's 4, 0 right there. We went down 2 to the right one, solid line. From there, again, not the best drawing, but I'm just going to go with it. And for this one, because it stayed a less than, now of course I want to solve it for y first before I make that decision, but this didn't change. It's still a less than. We want to shade below this line. So I'll draw little arrows to help me remember that. All right. But I'm not going to shade in anything just yet because I have a couple more inequalities to think about. This is probably the hardest one to do because of solving for y. I forgot to put step 1 here. And then, so step 1, subtract the 2x to the other side to solve it for y. Get negative 3y is less than or equal to 6 minus 2x. Then we divide by, let me use a different color than that. We'll divide by negative 3. Now, because it's a negative on both sides, we have to flip the symbol around the other way. Right? And so we'll get greater than. And then we're going to have, this will be 6 divided by negative 3. That's going to be negative 2. And then negative 2 over negative 3 will be positive. It doesn't reduce, so we'll just leave it as 2/3. And then we'll put the x to the side. We're going to graph this as an equation. So we'll graph this as, we're going to graph y equals negative 2 plus 2/3 x. So the slope is 2/3. We'll start at negative 2. So that's going to be right here. I'll show you the graph in just a minute. We'll go up 2 to the right 3. All right. And yeah, so this one, now I'm remembering, this is kind of a bad problem because this one actually ends up not really making a difference. You'll see here in just a minute. All right, so here's the graph. So starting at negative 2, we go up 2, which gets us back to the axis, and then to the right 3, which will be, I think on the other side, let me see here. So we go down 2 to the right one again. So this one actually is kind of off the mark. So maybe it does matter a little bit. Yeah, so I might be a little bit off here with how I drew this because this goes down 2 to the right one, down 2 to the right one. I should have been right here on this one, on this line. So it's a little bit higher than it should be. But this will cross right here. So this should be crossing more like right here. Does it make a difference? Let's see, and then we'll have, yeah, I guess we have all the information here we need. Below this line, no, yeah, just that still doesn't matter. So the last one here is, I'm sorry, hopefully you can still see all that. X is greater than 0. Step 1, we can't solve for y. And this time we can't solve for y because there is no y to solve for. So we skip that step. We graph it as an equation. We're going to graph x equals 0. Now x equals 0 is a vertical line. So again, I'm going to have to trace the axis here. I'll do the best I can with that. This is where x is equal to 0 right here. Oh, no, I did a good job drawing a straight line, just not on the axis. Let's try that again. All right, so it's on the y-axis. That's good enough. This is where x is equal to 0. Now, since we couldn't solve it for y, we can't think of this as shading above or below. But I mentioned it earlier, if you've solved it for x, you want to either shade to the left or to the right. That's how you want to frame that question. Greater than is going to be to the right. Let me try that again. happened there? Okay. Which would be this way, right? So I want to shade the region that satisfies all four of these inequalities. So let me zoom in here. That didn't work. Let's try that again. Okay. Shade in the region that satisfies all four. It needs to be above the horizontal line. So I have to stay above the x-axis, to the right of the y-axis, below the blue line, but above the green line. That's going to be this region. Again, it should be more, I didn't draw the line correctly here. So I'm sorry. I should have went from here down to the right one. It should have been right there, but I'll just leave it where it is. It's going to be this region right here. Okay. So it's below the blue line, to the right of the vertical line, above the horizontal line, and above this green line. But you notice the green line got crowded out, right? Anything above the horizontal line is already above the green line in this region right here. Now, if the region extended further this way, then the green line would have made a difference, because we have to stay above the green line. We have to stay up here, which would automatically be above the horizontal line. But since it got cut off over here, staying above the horizontal line automatically keeps us above the green line. So the green line just really did not make any impact on what the final answer was, which is unfortunate and probably shouldn't have happened. Maybe it was just I made a bad choice on the numbers that I picked when I put this example together. Anyways, I'm rambling now. That concludes the video on section 5.5. So you should go ahead and start on the homework and just let me know if you have any questions. Thank you for watching.